Good morning, everyone. Welcome to Now You Know. We're coming back off our summer vacation, and you know something, I can't think of a better way to start the new season with coming to Timber HP in Madison and giving you a chance to see everything that's going on here. It's amazing, and you'll see that very shortly. First of all, I want to thank Tim Curtis, Madison's town manager, for setting this whole thing up. Thank you very much, Tim. And I want to introduce our tour guide today, Jason Todd. And Jason gave me his card so I can get his full title in on this: Director of Building Science and Industry Support. And Jason, you're going to take us into the MAD lab, right?
Yes.
I almost call it Go Lab, MAD lab. And then also, and so you're going to give us some demonstrations and talk about products in there. And then also we're going to do a demonstration out in the garage that will show how fire retardant your products are.
Absolutely, looking forward to it.
Okay, so it's going to be an exciting program, and we'll get going.
So this demonstration here is a replica or a section of a typical house and the kinds of installation that you would see with wood fiber or more conventional products. One of the neat things that we feel we have to bring to market with our products is that it fits very much in conventional applications. So in the attic you might have a bat insulation. This is timber bat. We'll make various thicknesses for wall cavities, whether it's a 2x4, 2x6 construction, or acoustic applications with metal framing. The fill can also be applied. We'll take a look around the corner in a wall cavity behind webbing or in a retrofit situation like you would see cellulose insulation. And then with the changes in the codes here in Maine and throughout many parts of the US, continuous insulation is now required in new construction. And it's a good idea in a retrofit situation as well. And the board that you see would go over your house wrap. It could also work behind the house wrap. And that will add, with about 1.5 inch board, we'll get the required R5 in a 2x6 construction. You can see on the side here, I mentioned the fill fitting in the cavities. We've got an open cavity here, but essentially this is the baseline for all of the material that we'll be making. The wood furnish that becomes timber fill is the foundation for timber bat, and it's also the foundation for the board. In new construction, you might put a webbing over the bay and then fill that bay. In a retrofit situation, you'll pull the clapboards off, drill a hole, and fill a cavity that's most likely empty if it's pre-1980. I'll take you into the MAD lab and we'll look at some of the demonstrations. Board, hydrophobic, but still vapor open. Water flows down the surface of it, it sheds it. So in a wall application, the board is not going to become saturated. The paraffins and the binder itself actually provide a fair amount of resistance to moisture. So in a horizontal application or a roof application, if water does get behind your primary barrier, which would be the siding or the shingles on the roof, and it does get to the backside to the board where the insulation is, water will shed like off a duck's back, and that material will dry in time. In addition to this hydrophobic characteristic, it also allows a fair amount of moisture through it. It's still very vapor open. And the display on the wall there kind of shows a cross section of moisture and how it moves through the building. We generate a fair amount of moisture in our homes by cooking, showering, breathing. That can find its way into wall cavities. And if it's really cold outside, it can condense on your sheathing and it can cause structural issues. If you have a vapor open assembly and you're not wrapping your house in foam board, that will dry one way or the other, either back to the interior or work its way to the exterior. We'll come back to that display I'll set this one up too, and this is sort of a time lapse thing. It'll probably take 5 or 10 minutes, but essentially, this is talking about some of the thermal properties of wood fiber compared to other conventional insulations, and how R value doesn't quite explain enough in some situations. So we have a probe in between every one of these sandwiches. And so there's a thermocouple or probe in there, and that's tied to the bottom number on this display. And so they're all around 73 degrees, half a degree or so. And we'll give that a few minutes to warm up. And what you will see is that the foam board will actually rise in temperature. And that's the blue line here on the graph. And very quickly, the temperature will go up. Now, that's kind of interesting from an R value perspective, because it's the highest R value of those three products. So R value is resistance to heat flow. And this is heat flow and might replicate a wall or a roof in the summertime, where there's a great deal of heat gain on it. And even with the higher R value, you see a quicker temperature rise to within the core of the foam board, or into your house, if you will. And wood fiber will kind of stay flatlined. The graph kind of shows this. We'll see this as over time. The wood fiber will remain because it has a higher capacity to store that heat. In addition to good resistance to heat flow, it has a higher capacity to store that heat and delay the time that it takes to get into the building envelope where we are. Foam board has a very low capacity. So even though it might have a higher resistance in a lab setting, in the real world, there's opportunity when we have a cooler night, a warmer day, to wait out that heat with wood fiber because of its storage capacity. It holds it. By the time 16 hours passes in this display of 10, 16 minutes, you'll see that the temperature is still pretty close to 73 degrees where we started, where it will have spiked well over 100 degrees on the foam side and will be quickly joined by mineral fiber.
So Jason, this has the potential to keep the temperature more stable,
Exactly.
and therefore perhaps cut down on both heating and cooling costs.
Yeah,
in
and
a
just
house?
generally increase comfort. I mean, there's if it's going to stay hot all the time, it's eventually going to breach. It's going to get past the envelope, if you will, and there's no cooling phase, so there's no benefit there to better heat capacity. But for especially the Northeast, when you have hot days and cool nights, that natural cycle that happens, you'll find that wood fiber will excel because of its ability to slow that progress to a point where it won't matter anymore, and the cool night air will suck the heat back out of the envelope, if you will. You open the windows, that sort of thing. It has the potential, as we look at hotter and hotter summers and periods of the year, it doesn't have to be summertime, you end up with the greater demand for air conditioning, which increases cooling loads, and with wood fiber, we feel that a lot of folks, especially in the Northeast, won't need to add air conditioning to their homes because of that.
So there could be potential cost savings in both heating and air conditioning expenses over time.
Absolutely. Yeah, really good solid air R value, excellent performance overall, vapor open assemblies, a very safe building, but on top of that, especially during the cooling season, if you will, during summertime, additional cost savings and increased comfort. Whenever you can stabilize temperatures in your interior environment, you will be more comfortable. There's not a big temperature swing. You're sitting by the window and it just radiating that cold in the wintertime. You can feel it even if the temperature says 70 on your thermostat.
Is there any sense that, I don't know if I'm saying this right, but if for a similar value of your product versus the current product that is out there, what percentage of cost might it save in heating and cooling in an average house?
So as far as, it all depends on where you're starting from. We haven't done any of the numbers when it comes to the heat storage, the thermal capacity, but generally speaking, it's going to perform as well as any other improvement across the board when it comes to heating, and an increased improvement when we start talking about cooling, when you have that high and low temperature throughout the day. Another aspect of the density of the material, which is a component, and we can come back to that in a minute. We'll look at the temperature and where it's gotten to. Density is part of this storage capacity, but it's also the part of airflow. And insulation is good stuff. No matter what it's made of, it reduces heat transfer through an envelope. But airflow is also part of that conversation with the inside and the outside, if you will. So not only is the sun beating down on the wall make a difference, but if there's air leakage in that building, it's going to vent the conditioned air that you've created to the outside, or you could draw some of that unwanted hot or cold air to the inside of your building. So what we have here are two bats. One is fiberglass, one is wood fiber. Again, temperature on the bottom, there's a probe in the middle, and you can actually see the airflow moving through the fiberglass side because it's a much less dense product. Whereas the denser bat material won't let that ping pong ball float, if you will. And already we're starting to see a slight increase in temperature on the fiberglass side, and that is because regardless of the R value of the material, airflow is bringing good old incandescent heat into the cavity, compromising what we were hoping for of an excellent R value. If we step back to the diffusivity box display, you can see after just a few minutes we're at 80 degrees and wood fiber has not budged. Mineral fiber has also not budged, but in a few minutes that temperature rise will start. And there's a little bit of a math equation that comes together to explain all of this, but essentially it's how conductive the material is, the opposite of how resistant the material is, how dense the material is, and its heat capacity. I think, turn this off. We got 77 on this side with the airflow. And one of the other things that we really like about, turn this both. One of the other things that's really nice about wood fiber is because of the high density and broad application in walls, on the exterior of walls. It's great at sound reduction as well. We've got an annoying noise. And so it's really nice, and hopefully I can turn that off afterwards. It's gotten sticky over the years, but we talk about the comfort in, no, it's not going off. All right. We talk about comfort and what happens in the interior when we think about heating and cooling, but sound is part of that too. If you live by a busy road or loud neighbors, peace and quiet, it's general good health when you have a good sound experience as well. Better sleep, better studying, better work, just generally comfort. Unless you really just like things loud, but then you can step outside. But go back to the first display that we started with here. We're talking about vapor open assemblies. We boiled the water right out of that. And so you can imagine that this is representing the exterior of your wall. This is the rigid, continuous insulation, which helps with efficiency, increases the R value of the overall wall assembly. But when you use something that is vapor closed, it can trap that moisture and not let it pass through. What that means in a wall assembly is that all of that moisture is trapped where the wood sheathing would be. In the wood fiber example, they were boiling water at the same time. That moisture has made its way through, and you can see the condensation in the beaker. So vapor open assemblies, solid R value, much more durable, much more forgiving, and greater longevity. Zigzag you all over the place. We'll turn this off now, but essentially you can see that the highest R value material, R5, is now at 87 degrees, under 10 minutes of run time. We've budged about a half a degree on the wood fiber side. The mineral fiber has gone up a couple of degrees, and that will still climb even though we've turned it off, because it's a fairly porous material and doesn't have a great capacity for heat. It tends to continue in the same direction it's been going. We'll see a temperature rise. So you can picture this 4 o'clock, 5 o'clock in the afternoon. Sun's really kind of peaked at that point, 6, 7, 8. Finally, the nights come and things are starting to cool down. These other products are going to be radiating heat into your interior on the coolest part of the night for quite some time, where wood fiber has held it back long enough that you might not even need to open the window. You might welcome a little bit of warmth at that point in the evening.
So on a nice hot night with loud neighbors, I can count on a nice calm house and relatively cool inside.
Relatively cool inside, all good things. Yeah.
Sounds like good stuff to me.
Yes. Yeah.
Jason, I think the questions that come to mind from the general consumer. There you go.
I got it. There we go. Sorry to interrupt.
The questions that come to mind from a lot of consumers you've addressed as far as breathability, water resistance, fire is the other
Yes.
big question that comes up.
Sure.
And you guys have quite a bit of.
Yeah, we've got some
access.
things in the garage. We can open up the door and light some stuff on fire. Leave it
This'll
to
be
Tim.
fun.
Leave it to Tim to talk about
I always ask. Over on that table, John, is another answer to some people's questions, what the product looks like when it comes in. It's not coming in as 4-foot logs like we used to make paper out of, but it's coming in wood chips.
Yes.
And so that's a
Yeah, and that's a real important distinction. We're not harvesting lumber for the sake of making wood fiber. Our focus is on forest certified, local. These are producers that were selling chips to this mill and others in the state. They are producers that are very interested in this because a pine mill, a regional pine mill, which is good jobs, local product, has an overabundance of chips. It's a waste product for them, and it used to be revenue for them. So this will support businesses that support businesses that support businesses, and I think that's wonderful. It's not to say that there won't be some sustainable forest practices where there's some thinning of logs, but the primary use of or primary material is waste chips, softwood chips, and you could see that over here. Tim was pointing that out. Essentially, this is how it starts. We need chips under a couple of inches in size. This material gets processed, and I can kind of talk through that process if you like on one of our posters down here. Now, I don't. This. Engineering gave us an overlay of some of the stuff that's coming to the mill here. The original building, as you can see, in blue and white. Chips are brought in and then, as needed, conveyed into the building, into the refiner. The refiner is essentially like a plate mill that will grind up the chips. Those chips are also steamed to soften a little bit at first. Makes that refining a little bit easier on the chips. Some additional, in the case of fill, our first product, liquid boric acid will be added as a flame retardant. We'll get into a little bit of that in the Mad Garage. That flame retardant is fairly innocuous stuff. It's boric acid. This is borax, a laundry booster. This is what has been used for eye wash in dilute concentrations. Not much else gets added to the material, and it gets bagged. These are some of the European bags. These are a little taller than what we'll be producing. That same material, that same wood furnish that we create at the beginning, is used for bat and also for board. And since it's milled and wet, it's conveyed outside of the building to these very tall cyclones, still not half as much as the stack that's out there. It kind of dwarfs it, doesn't it? Those cyclones will separate some of the moisture, dry out the fiber at that point, where it is either brought back to the bagger for the fill, brought to bat manufacturing where some bicomponent is added to give it that structure, and it's baked in an oven into that structure, which helps provide a very good R value, as competitive as any other bat on the market. Or it is brought to the boards line right there, where there's some binder added to the ground wood furnish, and then it's pressed or formed into planks, into boards. Our motherboards are 4x8 in size, and then they are broken down with inline saws to smaller, more manageable pieces. We'll probably end up with a 2x4 size, just making it a little bit easier. We can produce boards from 3/4 of an inch up to about 9 1/4. And the density will vary depending on application as well. You can see this wall is actually made by about 2x8 European boards. Same idea, tongue and groove. To get a sense of the thickness of the material, this is something much closer to that 9-inch thickness, more than enough to add onto a 2x4 wall and meet code. And another thing that we hadn't really talked about, we could touch on briefly here and maybe again in the garage, is just cutting. The material is a little different than what's out there, but for contractors and installers, it's really not that much different. You can take a bat and split it if you need to wrap it around a wire. Very conventional tools, a jigsaw, a circular saw, a table saw, all of these things will cut the material. Depending on the density of the material, you might throw that on a table saw and you get a nice clean cut. And then hand tools work just as well, just a sharp serrated knife.
Now, time-wise, Jason, we were talking about getting up and running in 2023.
Yes.
And it's in stages, right? You're doing what, the fill part first, and then as the year goes along, you'll add the bats and then the boards.
Yeah, so we've got some rough by quarter, end of second quarter, we should be looking at the fill in production. And being the baseline in some form or another of all the rest of the products, that's a great place for us to start. The third quarter of the bat, the third quarter of the bat should be rolling, and then soon after that, the board in some configuration will be out sometime in the fall.
And employment-wise, my understanding is you're going to get up to somewhere near 120 employees as the year goes on.
Correct. I mean, we've got 20 some odd employees currently through the engineering team and marketing team right now, maintenance, and that is going to grow as well as we start building out additional folks on the sales force and business development, and then we'll expect to see 100 or so folks in the mill proper on the manufacturing side.
Now, you folks have the capability of really doing a lot for the forest products industry around here. I mean, the wood chips you're going to be, purchasing, and what do you, tonnage-wise, what are we talking about? Have any idea what's projected?
I don't have those numbers off the top of my head. We could dig them up for sure. Yeah, it is significant, and we have a pretty aggressive ramp up, and we feel that the market adoption will be very quick. That's part of the adding of so many folks on the front end as far as getting the word out there. But yeah, and we also have a great deal of support from a number of the smaller manufacturers of pine products, the lumber yards in the area, the logging community. As far as I know, I've not heard anything negative.
Yeah.
We're very supportive of them.
Well, the trickle-down effect, all of these parts of the forest industry could be pretty major, it sounds like. And of course, we had, 6 mills that closed in
Right,
the last
right.
5 or 6 years.
Yes.
And so they lost that outlet for these wood chips and so forth. So you guys, I guess, are going to pick up a fair percentage of that slack.
Yeah, absolutely. And we're seeing, wood products manufacturers that have the same dilemma of chip byproduct, waste product, if you will. Some of them are sending that material overseas. There's paper manufactured in China. Those chips are going there. That's kind of crazy to load a bunch of wood chips onto a container and send it overseas. And some of them are landfilling it because there's just no market for it. And there's, business drawbacks of that, but there's also carbon drawbacks of that. And we haven't talked too much about that, but I'll just say briefly that the carbon aspect of wood fiber as an insulation product is very powerful, and that's the fact that carbon, embodied carbon, it's about half of a tree. It's carbon. That will not be released to create carbon dioxide, to create a problem in the atmosphere if it's locked up. And by locking it in place from the chip, from the tree, from the chip, into the board or the fiber and putting it in your house is a great and easy way, a very cost-effective way to reduce our carbon footprint.
Maybe you'll help in the climate change battle that's going on.
Absolutely, and we
Yeah.
are the only conventional insulation product that's coming to market that is carbon negative from day one. When you put that in your building, your office building, your home, this Maine-made product will be reducing carbon footprint of that home.
I had read an article involving one of the founders of GoLab, Matthew Amelia. Is that
Yes.
how you pronounce it?
Yeah.
He was originally building energy efficient houses. I guess he's an architect and was
Correct.
doing that. And he was bothered by the fact that he's building these energy efficient houses, which would supposedly help reduce the carbon footprint, and yet the materials, the insulation he was putting in, that process made the carbon situation worse. So it was kind of a balancing act, and I think that led him, along with Josh Henry, to
That is
look into
absolutely
this.
it. The beginnings of this is a conversation to two folks that really care about things and want to make the world a better place, and building products is a great place to do that. We've had this dilemma in the industry for some time. We've talked about energy efficiency. We've talked about reducing energy use. That's also the operational carbon.
our mascot.
This is a pirate. How you doing, pirate? This is Inspector General. Marketing dog. I guess I totally lost my train of thought
That's
there,
okay.
Pirate, but
They're always upstaged by children.
embodied carbon. Matt and Josh got together, and I think the story goes, Josh was being shown one of the very low energy passive house buildings that Matt had produced, and it was wrapped in foam, and Josh was like, well, this is like a glorified beer cooler where there's a lot of carbon spent, if you will, by putting that all together. Being carbon negative from day one, very powerful. Very few materials are like that. And by putting it in buildings, you're locking it in place. It's a great fit for high-end, net zero, passive house. But because the cost of our raw materials is lower than it is overseas, the cost of electric and natural gas is lower here, And the transport, obviously, by not shipping it overseas, being produced here in Maine, will be much lower. We're going to be very competitive in the market and comparable to most other materials out there.
I don't think things are getting any better in Europe right now.
No.
By the sounds of it.
Yeah.
The one other thing I just, which I thought was fascinating, is you guys bought a mill in Germany, and then basically through, let me get the name right, Diefenbacher?
Diefenbacher.
Okay.
Yes.
Diefenbacher. And you transported that mill by boat in like 80 different shipping container
Exactly, yes.
crates over here,
Yeah.
which that's not a common thing, I don't
No,
think.
we are in the midst of that mill. Diefenbacher was instrumental in setting up in the first place, so it's great that we have the ability to have the same engineers recommission that equipment. The board manufacturing line was decommissioned by a manufacturer that was leaning towards furniture fabrication, like IKEA, knockdown furniture. Same kind of process as far as that goes. And they just decided they didn't want to produce insulation products. So it was a great opportunity for us. It was one of the first things that we ended up purchasing. It's been sitting over at Mac Point in Searsport for quite some time, and we've just started bringing those things over to the mill. I think they're all in a Chimbro yard down the road, and some of them have been opened up, and we're looking at getting the wiring in order, the engineers here, and just piecing it all together.
And also, you picked Chimbro, right, to do the construction process.
Correct.
I assume they're on site now doing
They are,
work.
yes.
Yeah.
And it's great to see them. It's a wonderful organization. I'm very glad that they were the ones that landed the contract. They've been hard at work right through the winter. Got a lot of work ahead of them, but seems like a top-notch organization. Great to have them.
And one other thing, you guys, I guess one of the things that clinched everything for you is you got some green bonds, was it, from
Yes.
through Fame
Yeah. So.
back in December?
Yeah, it was the end of last year. It was, $85 million of the $135 million that it's going to take to get this organization operation off the ground is supported by a green bond. It is essentially a solid waste recycling program that's supporting us, and we are essentially doing that with wood chips being a byproduct and a waste product. We're bringing those, instead of letting them go to waste, if you will, and actually release their carbon as well,
Yeah.
we're able to bring that back into a manufacturing process here on site. It's very exciting.
Very good. We got another place to go, right?
Yeah, let's go next door to the garage space.
Set some stuff on fire.
Oh, that's
So we talk about so the importance of a building material and fire resistance is about safety. Obviously, you don't want flammable materials in your home, but they do exist. That we treat wood fiber insulation with boric acid. Very simply handle the material. We're essentially doing what cellulose does in the recycled newspaper cellulose industry. And this gives us a Class A fire rating. So it is not flame proof, but for all intents and purposes, one of the best ratings that you can get in residential construction. And the advantage obviously is reducing the potential for fire. When a fire does happen in a home, the most important thing is everybody gets out safely. So that's about time. Class A fire products help us do that. Keep in mind that most of our homes, especially in the Northeast, are stick-built homes. It's wood that they're being built with. Wood's flammable, there's no question about that. You can treat wood and it will reduce the flammability of that. And so if you have a recycled newspaper product, you can see a little green coloring to the flame as it burns off some of the boric acid, but essentially direct flame, it self-extinguishes. Same thing on fiberglass. Fiberglass does not actually have that same treatment, but it's considered inflammable. It actually melts. So yes, it's not flammable per se, but fire affects it just the same. And then with some of the wood fiber, you have the same thing. This is actually a product from overseas, a little bit different chemical structure, but self-extinguishes. It's not likely that you're going to end up with a weed eater attacking your house. Mineral fiber. This is considered inflammable. Fiberglass tends to melt. We get to the bat. Class A fire rating with a chemical, self-extinguishing, and then the board is actually produced without any flame retardant, just the density of the board. So you could imagine that that board is in a vertical application on the exterior of your wall and there's a fire outside of the house. You can imagine that it is part of the interior of the wall or the structure itself. That's something that's going to resist fire. It's going to char on the surface and not much else. And any more intense flame than that, it's probably consumed the entire building at that point. There's plenty of time for someone to get out safely with the products as we'll be producing them. And we expect to get into the commercial realm to some degree as well. When we start talking about multifamily and multi-story with the board as an exterior in a larger fire-rated assembly. So it's pretty exciting stuff because people talk about bugs, they talk about water, and they talk about fire as the three major concerns. And I think we address all of those very well with a product that meets the needs of builders and installers, and also a product that can be considered familiar with just a little bit of orientation. It's very conventional in many ways.
So, Jason, my understanding is you guys are going to come in at a price point that should put you, make you market competitive
Absolutely.
as well.
Yes.
So this is very innovative, at least innovative in the US anyways, technology, and usually with most innovative new things, the price point's a bit higher for a while.
Right.
And that may not be the case for you guys.
No, we're not really interested in being the cheapest product available. I think we could probably go that route, but I don't think that does anyone any great service. It is a little different than what's out there in the market, and we really want to educate and inform and help train and really help people adopt this material because we really believe it's the right material to be using as an insulation product. And I really don't think there are too many downsides of it. The cost, we are probably going to be a little cheaper than some materials, but we're not going to be, we're not going to be cheaper than some of the lowest cost materials that are on the market. But we don't want to be in that market. We want people to really care about the work they're doing, to install things well, and to design a building as a system. Not just, oh, we need more of this, let's stuff it in there, and not really think about how it all comes together. We see buildings as systems. We see the envelope as a system, and when you put it together the right way, and it's pretty easy to do with wood fiber, it works well and it handles bugs, fire, and water. It's important stuff.
Very good.
And keeps you comfortable.
Now, when you first get up and running, what's your market going to be? Are you just marketing here in Maine initially, or are you going beyond?
The restrictions of where we will be selling is largely based on geography, but the Northeast.
Yeah.
We are talking with a few folks about distribution, and we are looking at a national footprint. Not all of this facility will handle that, although we expect that some materials will be delivered far away. We get a lot of interest from the Pacific Northwest and other parts of the country where we are, not ideal as far as the shipping costs.
Yeah.
But right now, those same folks, the early adopters, are buying material that's shipped overseas and then transported by rail and then brought to their local job site or distributor. The second location that we are looking at will be Pacific Northwest or somewhere along those lines. But I would expect, by the end of this year, we'll be talking about location number 2 because of the geography, because of the distance and shipping costs. There's no sense in transporting Maine's wood chips to the Pacific Northwest when they have plenty as well on site there, and we'll be able to produce locally, whether it's Washington State or Oregon or some other state out that way.
Well, as Tim has said, if you find another room in Madison, we'd love to have you build another one around here too.
Absolutely. Yeah. Well, I mentioned earlier, and Tim has talked about now. This is a long site and it's a narrow site. It was made for the paper manufacturing that happened here. The super calendar paper was produced here, and very fortuitous that a lot of the equipment, the board line that we brought from overseas, and the material that we're the bat line and the bagger that we're producing here domestically, having produced for us here domestically, will fit. We expect to stuff the end of the mill to its gills with product. And warehousing, we might need another building here in Madison to do some warehousing. We'll keep an eye out for that.
Well, Tim will promise that he will find you another building.
I'm sure he will. Yeah.
Now, you guys are the first in the nation to do this. I mean, this is not old technology in Europe, apparently.
That's correct.
They've got like 20 plus years they've been doing it.
Exactly. It's been going on for quite some time. There are some wet process board manufacturers here in the States. There have been for some time, and also in Canada. It's a slightly different process. We feel the dry process is less energy intensive. It gives you a little bit more flexibility so we can get greater thicknesses. And as far as I'm aware, no one's producing a bat product or the loose fill product that we would be producing. That is new to North America.
And it is new to North America, but with all I've heard today and how exciting this technology is, I can't imagine you're going to be all by yourself forever. Now, are you hearing any rumblings within the industry of other competition coming?
It's interesting. There's a fairly, as Tim can probably attest to, there's a fairly long ramp-up time as part of this process.
Yeah.
It's very involved. It's a very expensive operation to start from scratch. There's been some savings and creative strategy with existing buildings, for example, that happen to fit so well. We don't know of anyone specific to wood fiber. There are other bio-based materials, hemp-based materials. There's a hemp bat manufacturer out there. I don't know that they're doing a board product or a fill product. There are, like I had mentioned, the wet process board manufacturers. They can't get to the thicknesses without laminating them together.
Okay.
So that's a sort of a drawback. And the densities tend to be much higher, which reduces the effective R value. We're kind of hitting a sweet spot of strength, durability, and effective R value that we want, especially in the board product.
So you're going to have a head start.
I would say we have a good head start. There are distributors and manufacturers of other products that have sister companies overseas. Even though they have that advantage of a European manufacturer sort of in their umbrella of their organization. I think they're not as tuned into the market as we are with the strong team that we have. So even if someone else did step in, honestly, I think we'd welcome it because at this point we are really all about adoption of good strategies from here on out. And I think wood fiber is top of that list for us, and love to have somebody to bump shoulders with as we go forward. That'd be great.
Well, thank you, Jason. Tim, any other questions for
No, thank you for your time.
Sure
I'm
thing.
sure John will ask, but if we put your name on the screen, can you spell it for us?
I can give you a business card. It's
There you
pretty
go.
simple, but yeah. Yeah.
Perfect.
I don't have a bright yellow shirt on or a corporate logo or anything. I should have at least grabbed a badge or something.
That's okay. We'll vouch for
I've
it.
given up hats.
Yeah.
I got hats, but I just don't wear them much anymore.
There we go.
Awesome.
Well, Jason, thank you very much for your time. This has been a very enlightening tour, I would say, today. I'd also like to thank Tim Curtis, Madison's town manager, for being co-host and also setting this up for me today, because this is absolutely fascinating, and hopefully we'll be able to come back once you guys are fully opened and get a complete tour. That'd be great.
That would be great. I'd say half a year's time or so. And then give you a little walkthrough of the mill as we're approaching at least our first product rolling out the door.
Okay. Well, thank you once again, and now you know.